Question number 11. A person has 6 friends. In how many ways can he invite at least one friend to his house? Now again, at least one friend. Now total n is 6 over here, right? So total 6 friends he is having. From that, in how many ways he can invite at least one friend? At least means he can invite one friend also. He can invite 2. He can invite 3. He can invite 4. He can invite 5. And maximum he can invite 6 friends, right? So total combination we can write, total combination is equal to, from 6 friends, 1 friend he is inviting, that can be done in 61 ways. From 6 friends he is inviting 2 friends, so that can be done in 62 ways. Same way 63, 64, 65 and 66. Maximum 6 friends he can invite because he is having 6 friends, right? Now I'll solve this. 61, so that is equal to 6. Now 62, so 6 into 5 upon 2 into 1 plus 63, so 6 into 5 into 3 upon 3 into 2 into 1 plus 64, so 6 into 5 into 4 into 3 upon 4 into 3 into 2 into 1 plus, now 65, that is equal to 6, and NCN, that is 66, is equal to 1. Let's solve this. 6 plus, here it will come 2 into 3, so 15 plus, now here this will solve, so it will come 20 plus, this will solve, so it will come 15 plus 6 plus 1, so that is total comes to 63. Now next question is, in how many ways can 5 books be selected from 8 different books? So that now 2 conditions they have given, that is a particular book is always selected and a particular book is never selected. Now first we talk about that a particular book is always selected. Now we are having total 8 books. From that 5 books are to be selected. Five books are to be selected. The first condition is a particular book is always selected. So from total 8 books, 1 book is always selected. So that can be done in 1C1 ways. 1C1 ways. Now remaining books are 7, that is 8 minus 1, because 1 book is always selected. So remaining books are 7. So from remaining 7 books, how many books are to be selected? 4. So 4 books are to be selected from 7 books. So that can be done in 7C4 ways. So total combination is equal to 1C1 into 7C4. Now 1C1 is equal to 1. This will solve. So 7 into 6 into 5 into 4 upon 4 into 3 into 2 into 1. So 1 into, now this one will solve. So here it will come 35. So that can be done in total 35 ways. Now next condition is that a particular book is always selected. That is, particular book is always selected, that we have solved. Second is particular book is never selected, that is, it is never selected. Means 1 book we don't have to select only. So from 8, 1 we will subtract, because this 1 book we don't have to select only. So now we are having total 7 books. So from this 7 books, now we have to select 5 books. So total combination, that is, it can be done in 7C5 ways. 7C5, because now we are having 7 books and from that 5 books we have to select. So that can be done in 7C5 ways. So 7 into 6 into 5 into 4 into 3 upon 5 into 4 into 3 into 2 into 1. Now when we'll solve this, we'll get 21 as our answer. Question number 13. A student in standard 12th commerce stream has to appear for exam in 7 subjects. That is, total 7 subjects he has. It is necessary to pass in all the subjects to pass an exam. That is, he has to pass in all the subjects if you want to pass in exam. Certain minimum marks must be obtained to pass in a subject. In how many ways can a student appearing for the exam fail? Now total 7 subjects we are having, and he has to pass in all the 7 subjects if he want to pass in exam. So what they have asked, that in how many ways can a student appearing for exam fail? In how many ways can he fail? If he fails in one subject, then also it will be considered as fail. If he fails in 2 subjects, then also it will be considered. That is, if he fails in at least one subject from the 7 subjects, then also he is considered as fail. So total combination in which a student can fail, total combination in which a student can fail is equal to, that is 7C1 plus 7C2, that is, he fails in 2 subjects, plus 7C3 plus 7C4 plus 7C5 plus 7C6 and plus 7C7. That is, if he fails in at least one of the 7 subjects. Now 7C1, that is equal to 7 plus now 7C2, so that is 7 into 6 upon 2 into 1 plus now 7C3, so 7 into 6 into 5 upon 3 into 2 into 1 plus 7C4, so 7 into 6 into 5 into 4 upon 4 into 3 into 2 into 1 plus now 7C4, now 7C5, so 7 into 6 into 5 into 4 into 3 upon 5 into 4 into 3 into 2 into 1 plus now 7C6, so 7C6, that is 7 and plus 7C7, that is equal to 1. Now again we'll solve this. So 7 plus, so here we'll solve, so we'll get 21 plus, now this one we'll solve, so we'll get 35 plus, this will solve, so again we'll get 35 plus, now this will solve, so we'll get 21 plus 7 plus 1, so that is equal to, total is 127. Question number 14. In how many ways can a hotel owner subscribe 3 newspapers and 2 magazines from 8 different newspaper and 5 different magazines available in the city? So 8 newspaper and 5 magazines we have. From that we have to select 3 newspaper and 2 magazines. If a particular newspaper is to be selected and a particular magazine is not to be selected, then in how many ways can the selection be done? Now, first of all, from 8 newspaper we have to select 3 newspapers. and from 5 magazines we have to select 2 magazines, right? So that can be done in 8C3 ways, and here this can be done in 5C2 ways. So the total combination here is 8C3 into 5C2. I'll solve 8 into 7 into 6 upon 3 into 2 into 1 into 5 into 4 upon 2 into 1. Now I will solve this 56 and here 10. So total 560 ways. Now the condition which they have given, that if a particular newspaper is to be selected, that is that newspaper has to be selected and particular magazine is not to be selected. So if a particular newspaper is selected, from this one newspaper it has to be selected, so one will remove. From remaining 7 newspaper we will select now 2 newspapers, right? Now here a particular newspaper has to be selected, so then 2 newspapers out of the remaining 7 newspapers can be subscribed or selected in 7C2 ways, and a particular magazine is not to be selected. So now we are having 4 magazines, right? 5 minus 1. So from remaining 4 magazines we can select 2 magazines. So the total combination which we have is 7C2 into 4C2. Now we'll solve this. 7 into 6 upon 2 into 1 into 4 into 3 upon 2 into 1, that is equal to, now here it will come 21 into 6, so that is equal to 126. Question number 15, that is, if NP2 plus NC2 is equal to 84, then find the value of N. Now here we know the formula of permutation as well as combination. So what is the formula of permutation? That is n factorial upon n minus r factorial, and of combination n factorial upon r factorial in bracket n minus r factorial, right? So we'll bifurcate this. Now np2 plus nc2 is equal to 84, it is given. So we'll write down np2, that is n factorial upon n minus 2 factorial, plus, now nc2 what it will be there, n factorial upon r factorial, that is 2 factorial, n minus r, that is n minus 2 factorial, is equal to 84. Now here can we take out common anything? Yes, n factorial upon n minus 2 factorial from both this. So therefore n factorial upon n minus 2 factorial, and in bracket what is left now? Here this whole term is out, so 1 plus 1 upon 2, that is equal to 84. Therefore now we will expand is, that is n minus 1, n minus 2 factorial, and here also n minus 2 factorial. Now here we will take out the LCM, so it will be multiplied with 2 in numerator and denominator, so it will be 2 and plus 1, so it will be 3 upon 2, that is equal to 84. Now n minus 2 and n minus 2 will get cancelled, so therefore now we are left with n minus 1 is equal to 84. Now this will go here in multiplication, so 84 into 2 upon 3, so therefore n minus 1 is equal to, now this will solve, so we will get 56. Now n minus 1, so multiplication we can easily find out, that is 8 into 7 is 56, and that is n minus 1. So the value of n is 8 and the value of n minus 1 is 7. So therefore n is equal to 8. Next question, that is, if NPR divided by NCR is equal to 24, then find the value of R. We have to find the value of R. NPR divided by NCR is equal to 24. So NPR upon NCR is equal to 24. We will write down. Now we will write the formula of both. So what is the formula? N factorial upon n minus r factorial upon, now NCR, that is n factorial upon r factorial and n minus r factorial, that is equal to 24. Now here we can cancel, right? N factorial, n minus r. So what will be left? R factorial. So therefore r factorial is equal to 24. Now if we'll bifurcate here, r factorial is equal to 4 factorial, because 4 into 3 into 2 into 1, 4 3 is 12, 12 2 is 24. So 4 factorial is equal to 24. So r factorial is equal to 4 factorial. Therefore the value of r is 4 here.